Okay, so today we're going to have a lesson on adding and subtracting polynomials. We will add and subtract polynomials of degree 1 and 2. So just so you know, a polynomial will contain numbers, variables, and exponents. So I want to give you a few examples. So here we have a monomial, has numbers and variables. Here are some examples. We have 5x, x squared, we have negative x, negative 12. Okay, notice that these are just pieces to an equation that you have seen. The only thing you haven't really seen yet is x to the power of 2, but you've seen a 5x, you've seen a negative x, and you've seen a negative 12. When those are looked at individually, it's called a monomial. And notice there's multiplication going on here between our constants and the variable. So now if we have a binomial, this just means that we are taking two monomials and we are combining them together. So for example, if I had 5x minus 12, that would be a binomial. If I had negative x plus x squared, that would be a binomial. If I had negative 12 plus x squared, that would also be a binomial. Notice that these monomials, these terms, are now separated by a subtraction or an addition sign, okay? That's how you're going to be able to identify your terms, is by looking for addition or subtraction. Notice the only operation that we have not seen is division. If you have division, you do not have a polynomial. And for now, for a trinomial, we're going to take three monomials and combine them together. So if I had x squared plus 5x minus 12, that would be a trinomial. Another example would be x squared plus 8x plus 7. That would be another example of a trinomial. Again, I am looking for addition and subtraction signs to separate my terms to tell me how many parts I have. Next, we have naming polynomials. So we're going to touch briefly on this. Polynomials are named according to their degree and their number of terms. So for a degree, they have specific names. If the degree is 0, it's a constant. A degree of 1 is linear. A degree 2 is a quadratic. This is the highest degree that we will learn to solve in Algebra 1. But you do have a degree of 3 cubic. A degree of 4 is called a quartic, kind of like a quartet. 5 would be quintic, kind of like quintuplets. Now, degree is referring to the highest exponent number. Okay, so when you look for the degree, you are going to be looking for the highest exponent. And that's going to tell you the name. Now, if your exponent is 6 or higher, you are going to say blank degree, nth degree. So 6th degree, 7th degree, 20th degree, 21st degree, 22nd degree. So you're going to use those numerical words to describe the degree after 6 because they don't have a specific name like 0 through 5. The second name is going to come from the number of terms. So you could have monomial, binomial, trinomial, and I've given you some examples up here. Once you get to 4 or more terms, you're going to say the number term polynomial, 4-term polynomial, 5-term polynomial, 20th term polynomial, okay? And you put these together in a specific order. So you can think of it as your polynomial have a first name and a second name. Okay, the first name is going to come from the degree. So these names are going to be what you say first. So constant, linear, quadratic, cubic, quartic, quintic, nth degree. The second name is going to come from the number of terms. So it could be a linear monomial, a cubic trinomial, okay? So that's the order that you apply those names. So now I have a few examples down here, so we're going to see if you can apply these names to this. So again, we're going to start with our degree, look for the highest exponent. I see a 2, which according to the chart is going to be a quadratic, so that's its first name. And now I'm going to look for the addition or subtraction sign because that is going to help me identify the number of terms. That subtraction sign splits it into 2 terms, so that would make it a binomial. So we have a quadratic binomial here. All right, the next one. Again, we're going to look at degree, so we want the highest exponent number. 4, and according to the list, that is a quartic. And then we're going to look for subtraction and addition signs to separate our terms. And this separates our polynomial into 3 terms, so that tells me it's a trinomial. So we have a quartic trinomial. And for the last one, highest exponent is a 1. Remember that 1 is invisible, so it is a linear. And then I'm going to look for addition or subtraction signs to help me identify how many terms. And I see an addition sign, which tells me it splits it into 2 terms. So this would be a binomial. Okay. Now again, this is not something that we're going to necessarily be quizzed on. I just need you to be familiar with this vocabulary. So if you see the word quadratic, you know it's talking about the highest exponent being a 2. If you see a binomial, you know that it means it's got 2 parts, 2 terms, and there's either going to be an addition or a subtraction sign separating the 2. Now we're going to look at how do I add polynomials. So for our first example here, we have the trinomial, which is quadratic, so we have a quadratic trinomial, 2 times the value of x squared plus the value of x minus 5, and we're adding to it another quadratic trinomial, x plus the value of x squared plus 6. So you can think of this as having a positive 1 in front of your parentheses. Well, if you multiply anything by a positive 1, is it going to change the number or the sign of any term inside the parentheses? And the answer is no. So this is going to stay 2x squared plus x minus 5. All right. Again, I have a positive 1, and when I distribute that, it's not going to change the value or the sign of anything inside. So I'm going to have plus x squared plus 6. And now what I'm going to look for is I'm going to look for like terms. You have combined like terms when you were solving equations, but here's how it's different. You did not have to add anything or combine like terms when your power was greater than 1. And now we have exponents that are greater than 1. So how do I know when to combine? Well, first you have to make sure that their variables and the exponents match. So I always start off with the highest degree. So I ask myself, what is the highest exponent that I have in my problem? And here we have an x squared, x to the power of 2. So I'm going to circle every term that is x to the power of 2. And now I'm going to combine. So if you see, I have 2 here, and then I have 1 more over here. If I combine them, 2 plus 1 is going to make 3x squared. And now I'm going to look for the next term to combine. So I always go down in exponents. So the next would be power of 1. So I want to look and see, do I have anything with a power of 1? And I do right here. I'm going to draw a box around everything with a power of 1. So I'm looking for just my x terms, basically, x to the power of 1. Okay, well I have 1 here, and I have 1 here for a combined total of 2x. All right, now I'm going to look for my constants, because now I'm going to look for just my numbers that don't have a variable at all. So I have a negative 5 here and a 6. Okay, if I combine those, I have negative 5 plus 6, positive 1. And this is going to be my polynomial that I end up with. I end up with a quadratic trinomial, 3 times the value of x squared plus 2 times the value of x plus 1. And that is all there is to it, to adding polynomials. So let's look at our next example. I have this trinomial, 3x squared plus 7 minus 4x, and I'm adding to it this polynomial, which is cubic. I have 4x squared minus 8 minus x to the third. So again, if I recognize that I have a positive 1 in front of my parentheses, I can recopy everything, because multiplying by a positive 1 does not change the sign or the value. Since I'm multiplying here by a positive 1, I can bring down positive 4x squared minus 8 minus x to the third. Okay, now I'm going to start looking for my highest exponent number, and that is x to the third. I have right here. I see no other x to the third, so I'm going to go ahead and bring this negative x to the third down to my final answer. So I know I have negative 1 of my x to the third terms. Next, I'm going to look for my next highest exponent, which would be my x squareds. So I have an x squared here. I have 3 of them. And then, oh, I left off an x squared. Here. I have 4 x squareds here. And when I combine them, that's going to give me a total of 7x squared. Next, I'm going to look for my x terms. So I have a negative 4x here. And there's no other x terms to combine, so it's just going to stay the same. I'm going to bring down my negative 4x into my final answer, and now I'm going to look for my constants. I have 7, and I have negative 8. Okay, so if I combine 7 minus 8, that's going to give me a negative 1. So I ended up with a cubic 4-term polynomial for my answer when I combined my like terms. I ended up with negative x to the 3rd power plus 7 times the value of x squared minus 4 times the value of x minus 1.